This video gives a couple of examples of proofs of existence. Suppose you're asked to prove that a number or an object with some property exists. In other words, you're asked to prove a statement of the form, there exists an x, p of x, where p of x is the property. A constructive proof of existence finds a specific number or object that satisfies the property. A non-constructive proof of existence shows that there must be an object or number with that property without actually naming which one. A non-constructive proof of existence may use a proof by contradiction to show that this number or object exists. For example, suppose we want to show that there exists a number that can be written as the sum of two non-zero square numbers in two different ways. We can prove this by demonstrating such a number. And after a lot of scrap work and trial and error, I found that 65 can be written as 7 squared plus 4 squared, and it can also be written as 8 squared plus 1 squared. There are other examples too, but to prove the existence, I just need to produce one, and this is my constructive proof. Let's prove that there's some digit 0 through 9 that appears infinitely many times in the decimal expansion of pi. We're going to assume and use the fact that pi is irrational. It might be hard to prove this directly, constructively, so let's try an indirect proof. Let's suppose, for contradiction, that it's not true that there's some digit that appears infinitely many times. In other words, that every digit appears only finitely many times. So for example, we could let n0 be the number of times the digit 0 appears in the expansion, n1 be the number of times that 1 appears, and 2 the number of times that 2 appears, and so on. These are all finite numbers, so the total number of digits in the decimal expansion of pi is going to be just n0 plus n1 all the way plus n9, a finite number. So the decimal expansion of pi then terminates, which means that pi must be a rational number. This is a contradiction to the fact that we're using that pi is irrational, and so it proves that, in fact, there's some digit that appears infinitely many times. This was an indirect or non-constructive proof. Notice that we never named a particular digit that appears infinitely many times. In this video, we gave an example of a constructive and a non-constructive proof of existence.